Hi guys, today I am going to do midpoint theorem for you. Hope you will get clear on it. Okay, the midpoint theorem goes like this. The line segment joining the midpoints of two sides of a triangle is parallel to and half of the third side. So we need a triangle for this. Let's make a triangle and name it A, B, C, and midpoints of two sides of triangle. So let's take the two sides as AB and AC. So the midpoint of AB, let's make it point D, and the midpoint of AC, let's make it point E, and join these midpoints, you'll see a line segment DE. Now what is given here? We write given ABC is a triangle and D is the midpoint of AB and E is the midpoint of AC. So write in triangle ABC, D and E are the midpoints of the sides. D and E are the midpoint of the sides AB and AC respectively. Of the sides AB and AC respectively. TIVEL respectively. Now what you have to prove? To prove, we have to prove that the line segment joining the midpoints DE is parallel to BC. Again, DE is half of BC. So number one, what you have to prove from here? DE is parallel to BC. And number two, we have to prove DE is half of BC. DE equals to half of BC. Now see the diagram. D is the midpoint of AB, so this part and this parts are equal, and E is the midpoint of AC. This part and this part is equal. Now we need to do a constructions on the diagram. So how you make a constructions? From the point C, you have to draw a line parallel to BA, like this. Parallel to BA, name it F. Okay, from the point C, you have drawn a line parallel to BA, and you have to extend this DE up to the parallel line where the extended D line meets here. Name it as G. Name this point as G. So what you have done in the construction? From the point C, you have drawn a line CF parallel to BA, and you have extended this line DE up to the point G where this line meet the parallel line CF at the point G. So constructions, what you have made in the constructions, you have to write here. Constructions from the points from C, what is drawn? CF parallel to BA. CF parallel to BA is drawn. CF parallel to BF is drawn, and DE is extended, and DE is produced to meet D is produced to meet the line CF at Z. Meet CF at the point Z. This is the constructions we have made. Now we have to prove what is given. What do you have to prove? Now proof. Now you have to take two triangles from here. This triangle and this triangle. Triangle ADE and triangle EFG. C. Sorry, EGC. Right. In triangle ADE. And triangle ECZ. Triangle ECZ. Now we have to prove these two triangles as congruent. So how do you prove it? Now see here. See here, this angle and this angle, what do you call it? Vertically opposite angle, because the straight line AC and DG are the straight line meeting at the point E. So the angle this form is called vertically opposite angles, and vertically opposite angles are equal to each other. So we can write here angle AED, this part angle AED, and this one angle GEC is equal to angle GEC. The reason is vertically opposite angles, VOA, short form for vertically opposite angles. Now another part, what part is equal? Now see, from the construction we can see that this line CF is parallel to BA, and if we take this AC as transversal, then there is interior alternate angles formed. So what are the interior alternate angles formed? This one. This angle is equal to this angle. Why? Because CF is parallel to BA and AC is the transversal. So these are interior angles, interior alternate angles. So we can write here angle DAE. Angle DAE is equal to this angle. This angle is angle ECG. Angle ECG. Angle ECG. And what is the reason? Alternate angles. ALTERNATE. Alternate angles. Since what? CF is parallel to BA, and what is the transversal here? AC. AC is transversal. VERS transversal. Now these two angles, two pair of angles are equal. Now we can say AE is equal to EC, because we know that E is the midpoint of AC. So we can write it as AE equals to EC. What is the reason for this? Given. What is given? E is the midpoint of midpoint of AC. So with these three properties, we can say that this triangle AD and ECG are congruent. So therefore what you can write, triangle ADE is congruent to triangle ECG. How it is congruent and what is the reason for congruency? We can write, what is it? Two pair of angle and one pair of side is equal. So we can write angle side. Angle side. With the property angle side, we can say that these two triangles are congruent. And we know that when two triangles are congruent, their corresponding parts are also equal. So these two triangles are congruent. So what we can say now? We can say here that this AD is equal to GC, and we can say that DE is also equal to EG. Okay, we write now. We can write, therefore AD equals to GC. And what you can write again, another one, DE is equal to EG. DE equal to EG. Now AD is equal to AC. Okay, now what is the reason for this? The reason is corresponding parts of congruent triangles are congruent. CPCTC, corresponding parts of congruent triangles are congruent. Now in triangle in quadrilateral DBCG, in quadrilateral DBCG, now what we can say that by construction we have drawn CF is parallel to BA, and if CF is parallel to BA, we can say that CG is parallel to BA. We can say that CG is parallel to BA. CG is parallel to BA. This is why by construction we made it, by constructions. And another one. Now AD is equal to GC. AD is equal to GC. So we can write AD is equal to GC. This is proved here. AD is equal to GC. It's already proved here. So now in place of AD, what you can write? AD is equal to DB. AD is equal to DB. So you can write here DB in place of DB equals to GC. Why I am writing DB instead of AD? Since this AD and DB are equal, since AD equals to DB, because D is the midpoint of AB. Now what we can see here? What we can see here? We can see here that AD is equal to GC. That means, DB is equal to GC. DB is equal to GC means these opposite sides are equal. And here CG is parallel to BA. Parallel to BA means CG is definitely parallel to BD. So these two opposite sides of this quadrilateral are equal, and these two opposite sides of quadrilateral are parallel. So we can say that therefore opposite sides opposite sides of a quadrilateral, opposite sides of quadrilateral DBCG, DB and GC, DB and GC are equal and parallel. Therefore we can say that DBCG is a parallelogram. DBCG is a parallelogram. How can we say that quadrilateral is a parallelogram? If one pair of opposite sides are equal and parallel, then we can say DBCG is a parallelogram. Now we are in the end of the proof. Now if DBCG is a parallelogram, then we can say that opposite sides are equal. Similarly, we can say here that this part DG is equal to BC. We can say that DG is equal to BC. So we can write here, and also D is parallel to BC. So according to the properties of parallelogram, the opposite side DG is parallel to BC. Therefore DG is parallel to BC. So if DG is parallel to BC, then D is the part of DG. So we can say that DE is also parallel to BC. So therefore DE is parallel to BC. This is number one proved. Now we have to prove the second part. D is parallel to BC according to the question. The line segment is parallel to BC is proved. Now we have to prove this line segment D is half of BC. So how to prove it again? Just check it. Now, therefore, now here DE plus EZ, so we can say that DZ is equal to BC. DZ is equal to BC. Why? Opposite sides of a parallelogram. Opposite sides of parallelogram. So DZ is equal to BC. So now we have to prove DE is half of DC. So how do we prove it? We will prove it like this. Now DZ is mixture of how much? DZ means DZ is a part of DE and EZ. Makes DE plus EZ equals to BC. Or now see here, DZ means DE plus EZ. So I've written here DE. Let DE remain as DE plus EZ. What is the meaning of EZ? Here we have already proved here before we have proved here. EZ means we can write DE. So in place of EZ you can write DE is equal to BC. Since what is proved here? DE is equal to EZ, proved before. I show you here, it is already proved. Okay, now, or DE plus DE is 2DE is equal to BC. Or DE is equal to this 2 half BC. This is number 2 proved. So this is midpoint theorem. Hope you got it clear. So next time we'll come with converse of midpoint theorem. Thank you.